Welcome back again to Advanced Functions, MHF4U1. This is Trigonometric Functions unit. In this lesson number 4, we're going to take a look at the transformations to sketch the graphs of a primary trigonometric functions. And the units that we're going to use is going to be in radians. First, let's go over some of the transformation rules. So in the previous chapter, we did take a look at the transformation, the standard equation. So for sinusoidal, the first one, this represents for sine, and the second one represents the equation for the cosine. Now you will notice that the letters A, B, C, and D, they represent different transformations. First, let's take a look at A. Now, we're going to take a look at the absolute value of A. So what that means is that if A is less than 0, that means we say it's going to be reflected in the x-axis, meaning it's going to be downward. Now, if A is greater than 1, then we say it has been vertically stretched or expanded by factor of A. And if A is less than 1, so specifically if A is in between 0 and 1, then we say it's vertically compressed by factor of A. Next, let's take a look at D. If D is greater than 0, that means it's going to be we're moving vertically up. And if D is less than 0, that means we are vertically going down. So you will notice that anything outside the function, which is A and D, it represents vertical transformations. And another thing to know, something that's really special for sinusoidal, is that we have an equation of axis at y is equal to d. Okay, so this is new. Next, let's take a look at inside the function, b. So if it's inside the function, for b, you always have to take the reciprocal. So you're going to flip it. Now, if let b is less than 0, then we say it's a horizontal reflection through the y-axis. Okay. Now, if c is greater than 0, it's moving to the right. This is the only case if you take it out of the bracket. Okay, so right now you see x minus c. But if I take it out of the bracket, x is equal to c. So you switch the sign. And if c is less than 0, that means you are moving horizontally left by c units. And lastly, same thing for b, we are going to flip it. So if b is greater than 1, we say it's a horizontally compressed. And if b is less than 1, then we say horizontally expanded. So this is the case if you were to flip it. So for example, y is equal to sine 3x. In this case, I'm going to take it out of the bracket. So 3 is greater than 1. So that means it's going to be horizontally compressed. Another way that you can look at it is 3, take it out. So b is equal to 1 over 3. So if it's less than 1, it's horizontally compressed. Okay, so this rule applies when you take the b in the equation. Okay, so you see it as it is in the equation for that number. And something that's new is that we can find the period of the graph by saying t is equal to 2 pi over b. Another way you could do is period is equal to 2 pi over b. Okay. in this case b over here. Period, let's just represent p with 2 pi over b. So this is something that's new. Now, so what are some of the shortcuts that we can see from the equation? Well, in order to find the maximum value, all you need to do is d plus the absolute value of a, that's the maximum. To find the minimum, you do the opposite, you subtract d minus the a, because a represents the amplitude. Okay. Now keep in mind, amplitude always has to be positive. It can never ever be negative because it represents the distance. And the equation of the axis is d from the equation. Another way you can do it is you could find the y value of the maximum plus the minimum divided by 2. And the period is 2 pi over b. And the phase shift is represented by the letter C. Okay, so let's do an example to finalize this understanding. Now, just before we do the example, there are 5 key points that you have to pretty much memorize for sine and cosine function. So the key points are, for sine in this case, is 0, 0, pi over 2, 1, pi, 0, 3 pi over 2 minus 1, and 2 pi, comma, 0. So these are the 5 points. Now if I decide to do a cosine graph, again, it's same thing. Always divide it into 4 sections. So one cycle represents 2 pi. Right in the middle we have pi. And half of pi is pi over 2. And 3 pi over 2, which is 1.5. And 1 and negative 1. So for cosine, you always start at the highest. You come back at the highest. And right in the middle, you have the lowest point. And you have 0, 0. And these are the 5 points, 1, 2, 3, 4, 5. And you can curve in, out, out, and in. So this is for the cosine graph. Okay, key 5 points that you should memorize. So it will come in handy if you could just, understand how the sine graph looks like. So this is for sine, and this is for cosine graph. Sine and cosine. So this is for cosine. Again, just a reminder. Okay, y is equal to cos x. So in this case, I could write 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi, 1. You will notice that sine and cosine, they're exactly the same. They will have same A and same C. So hold on, let me write y is equal to A, sine B x minus C plus D. So sine or cosine. So they exactly pretty much have same y, the A value, B value, and D. The only thing that's different is going to be the C value, which is the phase shift. So in this case, to go from sine and cosine, all you need to remember is that they have been shifted 90 degrees, which is pi over 2. Okay, so if I were to shift pi over 2 to the left, in this case, so here, negative pi over 2. So shift pi over 2 to the left, then you are able to go from cosine to the sine graph. okay, in terms of one cycle. Okay, that's the only difference. They have the same amplitude, same equation of axis, and horizontal compression or vertical compression or stretch. Okay, so example number 1. Graph the function y is equal to cosine 2x plus 1. So first thing I want you to do is to identify what kind of sinusoidal function this is. So this is a cosine function. That means it's going to look like a U-shaped. Now first, let's describe the transformation. First things, we have 2 over here. So that's, if I were to take 2 out of the bracket, because it's in the function, so this, if I were to take it out, it becomes 1 over 2. That's my v value. So what that means, we have a horizontal compression by factor of 1 over 2. And then this 1 represents d value, which is 1. So it means we're going vertically up by 1 step. Okay, that's it. Now let's find the characteristics of the graph. As you can see, there is no number in front of cosine, meaning there is invisible 1 here. So therefore, amplitude is 1. I don't have any phase shift, right? There's no expression inside the bracket. So phase shift, there's none. Now the equation of axis is the d value. So axis, we could say, is y is equal to 1. And now it's time to find the period. Now to find the period, we know the formula. P is equal to 2 pi over b, or k. So it depends on the letter that I'm using in class. So in this case, my b, or the k value, is 2, which is 2 pi over 2. So therefore, my period is going to be pi. So first, I'm going to draw the parent function, which is cosine. So for cosine, we have 1, pi over 2 is 0, pi is -1, this and this. So this is my parent function of just cosine. Now we are going to do the transformation. So when you're doing the transformation, everything you can do all at once except for phase shift. So if you have a phase shift, that means I need to see 3 different graphs. So first, when you're doing it, always label your axis of symmetry first. In this case, my axis of symmetry is at 1. So at axis of symmetry, I'm going to draw a dashed line, just to show that this is going to be my middle ground. And then from the axis of symmetry, you're going to do the amplitude. So it seems like amplitude is 1. So that means my highest point is going to be at 2. So this is my maximum. And my lowest point, so you're going 1 step down from the axis of symmetry, is 0. This will be my minimum point. Next, we're going to do the period. So my 1 cycle is going to be pi. So that means I'm going to start at 0, and then you're going to end at pi. That's my 1 cycle. So what we're going to do, we are going to first label the highest point, maximum, at 0, 0. And then at pi, we're going to come back at the highest point. Okay, and right in the middle, we have the lowest point, which is the minimum over here. And then we're following exactly the same pattern. So in between, we have a middle ground at 0. So 0 actually represents 1 because this is the axis of symmetry. And right in the middle, we have over here. And then all you need to do is connect the points. Curved in, out, out, and in. So that is the one cycle of cosine 2x plus 1. So as you can see, it has been shifted up 1, and it has been horizontally compressed by a factor of 1 over 2. So it's half the size. So let's try the next example. So graph the function y is equal to 2 cosine 3x plus 1. Okay, so this is exactly the same idea as the previous one, but we have 2 here. So first, let's write the transformation, the description. So A is 2. So amplitude is 2. I have an equation of axis at 1. Do I have any phase shift? So phase shift is none. And let's find the period. So period, we said it's going to be 2 pi over k. So we're going to do 2 pi divided by k, which is 3. So in this case, it's not a very clean number, so period is going to be 2 pi over 3. Okay, we just leave it like that. So just by looking at this, I can conclude that we have a vertical stretch by factor of 2, which is the A value. And we have so for 3, I'm going to take it out of the bracket, becomes 1 over 3. You flip it. So because it's smaller than 1, we say it's a horizontal compression by factor of 1 over 3. And then we have a vertical translation, meaning up 1 step. Okay. So let's do the original graph for cosine. So again, cosine is 1, 1, 0, pi is 1, and this one. So this is my y is equal to cosine x. So in this example, I only need to have 2 graphs because there's no phase shift. Again, first things first, let's label your equation of axis. So equation of axis is at 1. So I'm going to draw a dashed line at 1. And next, we are going to do the amplitude. So amplitude is 2. So that means I'm going to move 2 steps from the equation of axis. So 3 is going to be my maximum point. And you move 2 steps down at -1, this is going to be my minimum point. Then the period is 2 pi over 3. So in this case, 2 pi over 3 is not labeled. Okay, so as you can see, the equation of axis, you can label it on your own, but we don't know how to go about doing this, right? So what you can do is figure out where's 2 pi over 3 is. So 2 pi over 3 is about 0.67. So it's around about here, over here. So right in between 0.5 and here. So right over here. Okay. Now, again, I told you to divide it into 4 sections. So what I'm going to do to find each unit, we're going to divide each unit. We're going to do 2 pi over 3 divided by 4. Okay, so the reason why you're doing it is to figure out what each square is going to represent. Okay. So when I do 2 pi over 3 divided by 4 using your calculator, you're going to get pi over 6. So what that means on a graph, when you're dividing into 4 sections, you're starting from 0, the end point is 2 pi over 3, and each unit is going to be pi over 6. And then the next unit is you're going to add pi over 6 to this. It's going to be pi over 3. Okay. So the reason why it's pi over 3 is because I reduced it from 2 pi over 6, which is pi over 3. Okay, and then again, you're going to add pi over 6 to pi over 3, then you get pi over 2. Okay, so these are the units that we are going to pay a close attention to. So it seems like we don't have pi over 6 here, so we know that pi over 2 is, so at around here, I could label this point is 2 pi over 3, and then pi over 2, and then 3 pi over 3, and then this is pi over 6. Okay, so now that we divided into 4 sections, as always, we're going to use the same pattern. At 0, it's my highest point, which is at 3. And at 2 pi over 3, we're coming back to my highest point, which is at 3. And right in the middle, for the cosine, you always have the lowest point. In this case, pi over 3, I have -1. And right in the middle, at pi over 6, we have the middle ground, which is here, which represents like a 0 for the cosine. And pi over 2, we have 0. Okay, so then you're going to connect the dots. In, out, out, and in. So make sure you exaggerate the curve line. And this is my final graph of y is equal to 2 cos 3x plus 1. Next one, so graph the function. So y is equal to 2 sine 3x, x plus 3. Pi over 3 minus 1. Okay, so let's write down all the given information. So A, amplitude is 2. We have the equation of axis, y is equal to -1. And it looks like we have a phase shift. So phase shift is, again, it's inside the bracket. So when you take it out of the bracket, you change the sign. So it's negative pi over 3. Okay, and then to find the period is equal to 2 pi over k or b. So 2 pi over 3, and that's my period. So using this information, let's do some description for all the transformation. So A is vertical, and it's positive, so it's greater than 1. So it's a vertical stretch by factor of 2. And for 3, you have to, it's technically 3 is inside the sine graph over here, right? It's inside the sine function. So 3, if I were to take it out, it becomes 1 over 3. So it's less than 1. So we say it's a horizontal compression by factor of 1 over 3. And for phase shift, we said it's negative pi over 3 because we take it out of the bracket. So that means we are moving horizontally. So pi over 3 left horizontally. Okay. So you never write negative pi over 3 left because left replaces, it shows that it's negative. And then we're going one step down, which is the vertical translation. Okay, great. So let's draw the axis. So I'm going to draw the axis over here. Let's say here and over here. So this is y and this is x. Again, we're going to divide it into 4 sections. So let's do 1, 2, 3, 4. So this is 2 pi, pi, pi over 2, and 3 pi over 2. And the highest point is 1. So I'm going to put 1 over here. And then this is negative 1. Okay. So if I'm drawing, it's going to be, for sine, where the graph looks like this. So you're starting from the center, 0, 0, right in the middle, 0, 0, and 2 pi, 0, 0. So right in the middle you have the high and the low, and connect the points. So this is up and this is down. So this is my y is equal to sine x. So for this graph, I need to show 3 graphs because there is a phase shift. So you do everything except for phase shift. Okay, so this will be my last graph containing it. So first, let's label the axis of symmetry. So it seems like my axis of symmetry is at negative 1. Okay. And then we have a which is 2 steps. So it seems like it's 1, 2. So my highest point is at 1. And then 1, 2. Oh no. So we are a little bit. So let's just. So this is negative 2. And this is negative 3. Okay. So we're going 1, 2. So negative 3 is going to be my minimum point. Okay. Now, the period is 2 pi over 3. So again, we're going to divide it into 4 sections. In this case, 2 pi over 3. So 2 pi over 3 is around here. Now, you could draw the axis relative to the original graph, or you could expand the axis if you like to make it a little bit more in detail. So I could like zoom in and make it into 4 sections. Okay, so I could say 2 pi over 3. So to find each increment, I said you're going to divide it into 4 sections. So when you divide it by 4 sections, you're going to get pi over 6. So each increment is going to be pi over 6. So pi over 6, if I were to add pi over 6 to pi over 6, you get pi over 3. I'm going to reduce it. And then you get pi over 2. Okay. So that means I can draw the sine graph here. So in the center, you have 0, 0, right? And then again 0, 0, and 0, 0. So over here, you have the highest point, and right in the middle, you have the lowest point. And I can connect the graph, the points. Now keep in mind that I have zoomed into the graph. So this is relative to my original function. So if I were to draw the next one, which is, let's do in red color, now we have to add in the phase shift. Phase shift in this case is pi over 3. So we're moving to the left by pi over 3. Pi over 3 is going to be half the distance of pi over 6. So that means this is going to be negative pi over 3. Right? Because I represented 2 squares as pi over 6. That means half of pi over 6 is going to be pi over 3. So I'm moving left by pi over 3 for all the key points. So I'm moving left. For this one, I'm moving left, and then I'm moving left here, and I'm moving left, pi over 3. And that's it. So connect the points. And this finally represents the whole transformation of the graph for the red one. Now, one thing that's different this time is you will notice that you have an expression, but the b value is not factored out. The b value, if there's an expression, it must be factored. So in this case, I could say y is equal to 3 sine, whatever it's in front of x, that's what you're going to factor completely. So 1 over 2, and then bracket x, and then you're going to do pi over 6 divided by 1 over 2. So when you do that, you get negative pi over 3, which is 1 over 3, bracket, and minus 1. So now b value, or the k, is completely factored. Then you can start writing all the characteristics. Amplitude is 3. The equation of axis is y is equal to negative 1. We do have a phase shift, which is, we're not looking the original, we're looking the factor form, which is x minus pi over 3. When I take it out of the bracket, you turn the sign. So it's pi over 3 is a phase shift, which is, I'm going to write phase shift, positive. And then we have to find the period. To find the period, again, is 2 pi over k, or the v value. So 2 pi divided by, in this case, is 1 over 2. So that gives you 4 pi. So on your calculator, all you need to do is just 2 divided by 1 over 2, and then you will get 4. Now let's write the description. We have for A, it's a vertical stretch by factor of 3. And for B, it's 1 over 2. So that means it's a horizontal stretch. The reason is because you're going to flip it. If I flip 1 over 2, it becomes 2 over 1, which is greater than 1. So it's a horizontal stretch by factor of 2. I'm moving right horizontally by pi over 3 units, and I'm going down vertically by 1 step. Okay. So let's draw the equation of axis. Okay, so when I'm graphing this, I want to keep in mind my middle ground is at negative 1. So it's going to be, let's try it this way. And I'm going to do 1, 2, 3, negative 1, negative 2, negative 3, and negative 4. 4. Okay. And I know when I'm labeling it, it looks like my period is 4 pi, so I will be needing a lot of space. So that means I'm going to let each represent pi. So it's going to be 2 pi. So this is pi over 2, and 3 pi over 2. So again, I will need to have 3 graphs. One graph representing a original sine function, which is 0, 0, 0, 0. Right in the middle we have highest. Okay, so keep in mind it goes up and down. So up and down. Let's do, in blue color, everything except for phase shift. So my middle ground, my equation of axis is at negative 1. So I'm drawing a dashed line. Then my amplitude is 3. So I'm going to go up 3 steps, 1, 2, 3. So my maximum point is going to be 2. And I'm going to go down 3 steps, 1, 2, 3. My minimum point is going to be at -4. And now it looks like my period is 4 pi. So that means I'm going to keep going. So 1, 2, 3, 4. So this represents 4 pi. So in the middle we have 3 pi. Okay. So that means I'm going to start. So for 4 pi, what are the units? I'm going to do 4 pi divided by 4 sections. And it's pi. So each unit of the square is represented by pi. So I'm going to circle all the 5 key points for the second one. So I'm going to start the original as 0, 0. So in this case, it's not 0, 0 because the center stage, the equation of axis is -1. So over here and right in the middle at 2 pi, equation of axis again, and at 4 pi, equation of axis again. Okay, so the equation of axis represents like the axis 0, 0. And then right in the middle at pi, we have the highest point. And at 3 pi, we have the lowest point. And you can connect the points. So this graph is everything. So y is equal to 3 sine 1 over 2 x minus 1. This is everything except for phase shift. Now let's incorporate phase shift. So phase shift is always the third graph. In this case, we're moving pi over 3 shift to the right. So in this case, we are moving about, because each square in this case is pi over 2, and we're moving about 0.33. So about over here. So this is going to be my new point. Again, not so much. New point over here, to the right, and to the right. Okay. So this is my final graph that has been shifted pi over 3 to the right. Okay, so this is my final graph. So let's describe the transformation in this function. In this case, there's no number in front of x, so I don't need to factor anything. So a is equal to 3. So that means it's a vertical stretch by factor of 3. There's no horizontal stretch or compression because it's just 1. And we are moving, so negative pi over 3, if I take it out, it becomes positive pi over 3. So we are moving horizontally by right pi over 3. So you could write horizontal or just write pi over 3. And then 2, we're moving up, which is the vertical translation, up 2 steps. Next, you will notice that inside the function of cosine, we have an expression and 4. So we need to factor it. So y is equal to -1 over 2 cosine square bracket. So factor completely whatever it's in front of x. In this case, there's invisible 1 here. So 1 divided by 4 is going to be 1 over 4. So pi over 4. And close the bracket. Now that we are finally factored, let's take a look at it. If there's a negative, especially outside the function in front of a, that means a vertical reflection through the x-axis. Okay. And then you look at the a value. A value, it's 1 over 2, so it's smaller than 1. We don't look at the negative because the negative signifies it's a reflection. So you look at just the absolute value of the A, which is positive. So it's a vertical compression because it's smaller than 1 by factor of 1 over 2. Now for K, or the B value, it's 4. So when I take it out of the bracket, it becomes 1 over 4. So it's horizontal compression by factor of 1 over 4. And then we're moving right by pi over 4 because it's negative pi over 4 in the bracket. So when you take it out, it switches signs.